fun. All right, so example 7 is the last example we're going to do with the mean value theorem. Remember, the mean value theorem says what? Here's your redemption right here, Ethan.
I wasn't here whenever we went over it.
I know, but you watched the video.
No, yeah, I was. There's a middle value. I don't know.
No, M does not stand for middle. Intermediate value theorem, I stands for middle. You're thinking of the chicken crossing the road. The mean value theorem says M is for mean, right? Which means average. So it means that if the function is continuous on the closed interval and differentiable on the open, all right, then there has to be a point strictly on the interior. That's what makes it different from the other two theorems where they allow endpoints to be candidates. This one has to be strictly on the interior where the instantaneous rate of change at any given moment equals the average rate of change over the entire interval, or the other way around, right? So in the result of the guy that's speeding, because his average speed was 75 miles per hour by the mean value theorem, since his position on that 5-mile stretch was continuous and differentiable, there had to be at least one time where he was going 75. And it's irrefutable. So there are some places that use the mean value theorem, like in NASCAR. I'm not a big NASCAR fan, but when cars come into pit row, they can't go too fast, so their time is penalized. They actually clock them. There's like a little sensor at each station, and it calculates how long it takes for them to pass in between those sensors. And if their average speed in between those two sensors coming into pit row is beyond some certain threshold, they know that they were going that speed at least once, and their time is penalized. So NASCAR, of all things, uses the mean value theorem in pit row. And I always thought, like, if I was like running the highway, those when you drive, if I were running the country, the toll roads, right? You drive on the toll roads and you don't even have to stop now and throw coins or talk to a person in the bucket, right? You drive on a toll road and you drive under one of those toll signs and you see the bright lights as you're, whoa, right? They take your picture. And you just keep driving, like the one that goes through Austin right there, the Austin toll. And then like a month or a couple of weeks later, you get a little bill and it says, hey, you were driving on our road. Please pay this. It's super convenient. Now, those speeds on those toll roads are pretty high, aren't they? Like it's like 85. It's like 85. Yeah. But when the speed limit's 85, that means you can drive what? 100, right? And you know how easy it would be for them, since they're taking your picture at consecutive tolls anyway, so they know how much to bill you. It would be so easy for them to also compute your average velocity between those two photographs, right?
Do they do that? No.
They don't, but they certainly could. Like, I mean, it's just a phone call away. Hey, guys, you know how you can increase your income passively with technology that you already have? I will write the code for you if you just give me 0.05% of the proceeds, because I'll be rich, because everyone speeds. And it's an easy thing to do. The mean value theorem can catch you speeding in between toll stations, and there is no refuting it, okay? Now, what does that mean in terms of the graph? That means that the secant line slope is equivalent to the tangent line slope at least once. All right, now here's another application, right? Another application. Suppose that f is differentiable for all x. If something is differentiable for all x, you know it's also what for all x? Continuous for all x. So the MVT is going to apply anywhere and everywhere. All right. It says, suppose that f of 0 is -3 and the derivative is less than or equal to 5 for all values. What's the maximum value of f of 2? Okay. This problem doesn't seem out of the box like it's a mean value theorem question, but you can answer it intuitively. Watch. When in doubt, just plot it. 0, -3. So there's -3. I'm starting there. And I want to know by the time I get to f of 2, there's 1, here's 2. I want to know what is the biggest it could be. What's the biggest that y value can be? Well, what's keeping me from going up like super fast? I'm told that the derivatives are never bigger than 5. The slopes of the graph are never bigger than 5. So if I want to know the maximum value, I should try to increase at the maximum allowable rate. Yes, I should drive the speed limit, in other words. So let's go from x equals 0 to x equals 2 at the maximum limit of 5. 5 is the slope, so that's 5 over 1, right? So let's go up 5. 1, 2, 3, 4, 5. That puts me at 2 over 1. And now I go up 5 again. 1, 2, 3, 4, 5. That puts me where? At 7. Boom. So right now I'm at the 0.27. That would be the maximum value. If I was going up, pedal to the metal the whole time at the maximum allowable rate, I would be at an altitude of 7. Could I be under 7? Yeah, because it says less than or equal to 5. So I could go up at like a slope of 1, or I could even go a slope of 0, right? And I can even have a negative slope. But the largest it can be is 7. So you could just say f of 2 then has to be less than or equal to 7. Did that seem like a mean value theorem question? No, but it is. Here's another way to answer it. It's not always going to be so intuitive from left to right. Here's what we know. Because it's differentiable for all x, we know that the MVT applies. So here's what we know. By the MVT, we know that the derivative has to equal the average rate of change. Well, I'm going from 0 to 2. So f of 2 minus f of 0 all over 2 minus 0 has to, if that's equal to f prime, and if f prime is truly less than or equal to 5, then the average rates of change have to be less than or equal to 5. And what I've done now is I've set up this inequality. Let's go ahead and solve it. I don't know what f of 2 is. Do I know what f of 0 is? It says it's -3. So f of 2 minus -3 all over 2 less than or equal to 5. All right, let me multiply both sides by 2. It'll divide out over here. So I get f of 2 plus 3 is less than or equal to 10. And now I subtract 3 from both sides. And I get f of 2 is less than or equal to 7. Is that the same result we came up with intuitively? Yeah, but it's very straightforward. It's a calculation. Okay, so when you get back from lunch, I'll have you do the next one. And if you want to try to do it intuitively, you can, but it's a little bit harder because we have a negative slope and we're going backwards. So you have to do extra thinking. But if you want to set it up using the mean value theorem, it's going to be a little bit easier. Okay, so I'll pause this and we'll come back to it. Have a good lunch. All right, 7B. Just talk us through it. Ethan got 14. How'd you do it?
Well, the most it can be decreasing by is -3. And so from 1 to 5, the most it could have been decreasing was -3. So it would have decreased by 12. So I just added 12 to 2.
And got 14?
Yes.
Yeah, that's good logic. Yeah, that actually works. Okay. You don't have to do this problem necessarily with the IVT, but this one is a little bit more challenging because it's giving you essentially a minimum slope, but you're going backwards. So I think it's easier to just say, oh, it's differentiable for all x. So on any interval, MVT applies. I know a y value. I'm trying to find another y value, and I know a slope value. So it's kind of like a formula. Remember, the mean value theorem says f prime of x is equal to f of b minus f of a all over b minus a. So if you think of this as a formula, it has 1, 2, 3, 4, 5 unknowns. And if you know 4 of those 5, you can solve it, right? Well, we do know 4 of the 5. So we can go ahead and plug it in then. We can say then that has to be, well, let's go ahead and just plug in our values. F of 5 minus f of 1 all over 5 minus 1, or f of 1 minus f of 5. Either way, over 1 minus 5. We know that since it's equal to f prime, has to be greater than or equal to -3. And now we can plug in for f of 5 if you want. That's 2 minus f of 1 over 4. And this kind of gets into what Ethan said. We're spanning 4 units of x. So if you multiply both sides by 4, algebraically, you clear it out and you get -12. That means the most by which it could have decreased was 12, as he said. So if you're continuing it algebraically and you leave the the negative on that side, you get negative 14, right? But we got to solve for f of 1. So algebraically now, if you multiply both sides by a negative, what are you supposed to do with the inequality? Flip it, right? Less than or equal to positive 14. And then it should match up. It says, what is the largest possible value? Well, when it says f of 1 is less than or equal to 14, is that 14 then the biggest? If it said greater than or equal to 14, then 14 would be the smallest, right? So the inequality has to match up. So yes, we know then that 14 is the maximum value. So again, mean value theorem, whenever you're trying to prove, if we're getting into the big three worksheet, if you're ever trying to prove a y value, oops, I wrote y twice, right? If you're ever trying to prove a y value, you're going to use the YVT, also known as the IVT, right? IVT, YVT, they rhyme. But if you're ever trying to prove a slope value or a derivative, then you're going to use the MVT, which is the MVT, right? In this case, this M is your slope from algebra 1. So slope VT is the MVT. If you remember, y equals mx plus b, m is your slope. So anytime you're trying to prove a slope or derivative, it's not the YVT, it's the MVT. Okay. All right. Then we're through. We're through. So you have the rest of today, and what did I say? All of tomorrow. Is that right? Yeah. Okay. And then Wednesday, I'll sneak in a real quick 3.3 that we'll return to after the break. And then Thursday, y'all have the entire class free to work again. I won't be here that day. I have like 3 different tests with my new cardiologist. It's going to be a fun day. She told me to bring my running sneakers. Yeah. I don't have to have a nuclear stress test. I can actually have a real stress test because I'm young and unfit. Whatever. Yeah. What's that? A nuclear stress test is someone who can't run on a treadmill. They inject them with a nuclear peptide that simulates stress like running on a treadmill. So they're sitting in a chair and they get injected with something that makes them go crazy. Yeah. Yeah. I don't really care for that. I was like, no, I'll run on the treadmill. Yeah, yeah. And then I gotta have oh yeah, yeah. Oh, right. Look out. State champion. That could be your new motto, right? Before you go in there, I'm gonna go nuclear on you. Right? That could be. All right. All right. We're done.